Hello everyone, welcome to Algebra 2 homework 1.5 absolute value equations. This is right after doing the 1.5 homework, so if you have those notes or you are struggling to remember exactly the right steps for solving an absolute value equation, let's pull them up, have them right next to you. We'll jump into it. Let's see, evaluate each expression if a equals -5 and b equals 6. So absolute value of -3b would be -3 times the value of b, which is 6. -3 times -6 is -18 absolute value, and that would just be 18. That's what we're looking for there. Let's see, 2. The absolute value of a minus the absolute value of b. So these are all independent, of course, so treat each of these as its own absolute value. So absolute value of -5 minus the absolute value of 6. And once I have single values, I like to change all of them into just standard values. So the distance that -5 is from 0 is just 5 minus 6, and 5 minus 6 is -1. That's what we're looking for there. And 3 times the value, or the absolute value, of a minus 2. Let's see, 3 times absolute value of -5 minus 2. Let's see, 3 times absolute value of -7. So that's just 3 times 7. So that's just 21. Easy enough there. Let's see, solve each equation and check your solutions. So, important step. This first one, they've done some of the work for us. The absolute value is already by itself, so we can split this into separate equations right away. Let's see, we'll do the positive first. So for the first one, we don't really need to distribute any negatives or anything, so it's just 3x minus 3 equals 2x minus 2. And the other one, if we distribute a negative into this absolute value field, we would get -3x plus 3 equals 2x minus 2. So now we just simplify these down. I'll kind of work on both of them at once. So we'll add 3 to each side here, subtract 2x from each side, so that would give us x equals 1. So that's one of our solutions there, x equals 1. For this one here, I will add 5x to each side, and then I will add 2 to each side. So that would give us a 5 over here. Those would cancel out. Those would cancel out. So 7x. All right, easy enough. Let's see. We'll divide each side by 7. So that would be x equals 5/7. And now we can check our solution. If you watch till the end of my notes, or I went over this in class, really you're just checking to see if this value, when we plug in an x, is positive or negative. If it's positive, great, that works out just fine. If it's negative, then we have a problem. So let's see, if we plug a 1 in here, we would have 2 times 1, which is just 2 minus 2. So 2 minus 2 is 0. Can the distance from 0 be 0? Yes, that checks out. If it's not positive and it's just 0, that's fine. So x equals 1 is definitely a solution. What about 5/7? Let's see. 2 times 5/7 would really just give us 10/7. That's minus 2. And if we want to, we can write this as 14/7. That's just another way to write 2. And let's see, 10 over that would be -4/7. Oh, what did I do here? That's not over 2. That would be 14/7 to equal 2. My mistake there. So yeah, -4/7. That'd be a negative number, and the absolute value of anything cannot be negative. So x equals 5/7, this potential solution that we found, is not correct. So really, the only solution that we're looking for is x equals 1. That is it. What about this next one here? 1/7 of the absolute value, 3x minus 4 equals 2. All right. First thing I would do is multiply both sides by 7 to get rid of that 1/7 here. So that would give us the absolute value of 3x minus 4 equals 14. I'm going to write this a little bit closer up. Spare me just a moment here. let's see, 3x minus 4 equals 14. All right, and now we can split it. And this is a stage where you can pause and think, the variable is not on this side. So really, if we want to, we can realize that if we find two solutions here, they're both going to be valid. Regardless of what we plug in here, as long as we do our arithmetic right, we should be able to get to a distance of 14. Let's see, so the first side of this, the positive, so 3x minus 4 equals 14, and the negative side, we'll just distribute the negative in. Negative 3x plus 4, remember, it's all the values there. Let's see, equals 14. I'll subtract 4 from each side here, so negative 3x equals 10, divide both sides by negative 3, so x equals negative 10 over 3. And even though this is negative, that's fine, because once we plug it in to this side of the equation, we're going to get a positive number anyway, so no worries there. What about this left-hand side? If we add 4 to each side, we'll get 3x equals 18, and that would be x equals 6 once we divide both sides by 3. And we know that we don't really need to check because regardless, remember, what we plug in to this side of the equation, it's going to be a positive number. We're not going to come up to a situation where we're asking for the absolute value of something to equal the negative. So we're just fine. What about number 6? This one's almost fine. We just need to get the absolute value by itself. So we can subtract 2 from each side. That's the absolute value of 14x minus 3 equals negative 1. Now, because of the checking that we've been doing, if you realize that we're asking for the absolute value to come out to a negative, you can stop right there and just say there's no solution. That is fine with me. It'll show that you actually know exactly what we're doing with these absolute value equations. So we're all set there. What about number 7? First thing, divide everything by 3. So that would cancel out those 3. We'd have the absolute value. Again, I'm going to write this a little bit closer up just to save on space. So that would be the absolute value of 2x plus, well, what am I doing? Not plus 4, plus 7 equals, and divide the 3x by 3, that would just be x plus 4. Easy enough. Split this into 2. We have 2x plus 7 equals x plus 4. And we also have negative 2x minus 7, distributing a negative into the whole thing, equals x plus 4. And let's jump through and solve it. So on this left side here, if we take away an x from both sides and take away 7 from each side, we'd be left with 1x on this side equals, let's see, 4 minus 7 is negative 3. Okay, we'll have to check that because we have more than just a positive number on that side of the equation, but we'll get to that. Let's see. We'll subtract x from this side and add 7 to each side, so we'll have 3x equals, those cancel out. 4 plus 7 is 11. And that would give us x equals 11 over 3. Okay, perfect. Let's see. If we plug in the negative 3 here, we'd be positive, just barely. Negative 3 plus 4 would give us 1, so this one checks out. And we can go to the trouble of rewriting this as 11 over 3 plus, what's that going to be, 12 over 3, and then adding them all together. But if we realize that we're going to take a number and add it to a 4, and that number is positive, we can skip all that and say, yeah, that's positive. So they both check out. So it's going to be negative 3 and 11/3. Now let's jump over to what I know all of you guys were just anxiously waiting for, word problems. Let's see. What did I do there? There we go. Okay. Let's see. Some say that to brew a perfect cup of coffee, you must have a brewing temperature of 200 plus or minus 5 degrees. Write and solve an absolute value equation describing the maximum and minimum brewing temperatures for an excellent cup of coffee. So to start it off, we need to realize that if we're starting at 200 and we're looking for a difference plus or minus of 5 degrees, really we can write that as 200 minus some variable. We'll just say x because x is always used. But now what? Really, if you think about this, you mean, well, 200 plus or minus, you could say that's 195 or 205, but we're looking for this difference to equal 5 at its maximum. And we're just looking for the maximum and minimum, not the whole range in between. The next section that we'll look at is going to say, well, what if this difference has to be less than 5? And then we'll figure out how to do that. But for now, we're just focusing on the equal sign. But this could be negative, unless we just do absolute value. And now it's very simple. We can split this into 2. So we have 200 minus x equals 5. And we also have negative 200 plus x equals 5. And then we solve both of these out. We can add an x to both sides and take away 5 from this one. That would give us 195 equals x, or x equals 195. And that's one of the solutions there. And then for this one, we can just add 200 to each side. And that would give us x equals 205. And that proves what we kind of our intuition, that 200 degrees plus or minus 5 degrees would give us either 195 degrees Fahrenheit, 95, or 205 degrees Fahrenheit. And what about this next one down here? Let's see. A junior carpenter is following plans for a new kitchen table they are building for their family. The legs should all be between 29.9 and 30.1 inches long. Write an absolute value equation for the lengths of the table legs. So what we're looking for here between 29.9 and 30.1 is the spot right in the middle. Because these are pretty nice and round numbers, we can see that each is just 1/10 off of 30. Right in between them is going to be 30. When you're dealing with two slightly different numbers, like this down here, we'll see the equation change very slightly. But if we're looking for the maximum distance being just 0.1, we know that whatever we have in this absolute value bracket, the distance is going to be 0.1. Perfect. Let's see. So now we just need to figure out what to put in the middle. If we do 30, right where we start, minus, and that's important, the minus, because we're looking for a difference between the two, of x, that would be exactly what we're looking for, because then we can have x equal either 29.9, and that would give us 0.1, which would match right there. Or if we do 30.1, that would give us negative 0.1, and that would match up right there as well. For this next one, if we were to rewrite the equation from question 9, this one that we just came up with right here, but the range of 29.8 and 30, what would we have to change? The distance, or the maximum difference, the maximum margin of error, I suppose, being this 0.1, would not change. So we would want to rewrite this number right here, but what number do we pick? We would have to pick the number between 29.8 and 30. We can do that by either just kind of crunching those numbers in our head. Halfway between the two would be 29.9, or we can add both of the numbers, 30 plus 29.8 over 2. We're just finding the average here, and that's going to come out to what you would maybe expect, 29.9. So to rewrite the equation from number 9 to match this new range, we would write 29.9 minus x equals 0.1. And that's everything. If you guys have any specific questions about anything like this, please see us in class, send us a note on Canvas, and we'll do our best to respond as fast as we can. See you guys next time.